take me away from home. Show me all the places I've never known. And we'll chase the night, erase all of these broken dreams and flight. And we'll up here, we're free, bound only by frozen memories. Lost inside, erasing all these broken dreams tonight. And we'll
Good morning, or whatever it is, wherever you are. In watching the rollout of the activity maps, I was watching some of the scheduled tasks to update the data, and noticing that we're apparently exceeding the memory size of the little tiny instance that's running that. Which isn't fatal, but it does cause it to go to swap and run slower. And I think something else that's happening is the random sig terms we get from time to time are the result of web scale down killing all processes, not just web processes, which might be its own issue. But we still reduce our vulnerability time if we process faster. I know in one case I saw it die in the middle of a very, very slow process of doing the activity maps, which there's many, many layers of them. And when I restarted that, it only had to redo the activity map portion, and that went much faster. So I need to figure out some techniques for measuring memory and seeing exactly where we're leaking at. I mean, I can take a look at some of the obvious things. I mean, I guess there's this. I think this probably involves a large string, but I would think that this thing would go out of scope and be collectible. S3 Oh yeah, copy it into the string, rewind it, put the object, but this is a local variable here. It's like I could deliberately say it's nil, but that really should have gone out of scope. Unless they're like, oh, well, you could have, well, I mean, even if I zero it there, it could have been saved here, so. I mean, I guess this block could deliberately zero it. That's really value, not it could have been saved. These things could be hanging on to memory. I tried to, whenever we yield something to, well, to replace it. Well, I guess these do copy key. And then our final one doesn't. But once again, this block should be ending. At which point we should no longer have references to that. Let's close the file. The file is just a buffer, and maybe I need to do, well, the input file is going to be the same for all passes. I might need to do something with multiple passes. I guess memory leaks. 2.5 and above. What did we end up with on the new computer? .6. It's a gem. Okay, so script.rb might be a little bit challenged in the Rails environment. But I need something. Or I can just require it. Oh, but you have to do your code in a block. Or start stop, okay. So I don't know how much of this is going to be this thing versus my little local script. I might need to do both and see if there's any significant difference. No. So it'll be easier to just do locally here. No, I don't have you open there. I guess it would only be a gem dependency if the package ended up having some of this stuff kind of sitting around in case it got activated. In any case, I can take it out. Oh, I've only done runtime dependencies here. Is it development? Memory profiler. Gem version 100. Okay, so this is actually misspelled. Development. Now, if I start here, I can't actually use the script form, but I think I'm going to have to use the inline form, or the in script form for the other things. No, you. All right, so I need you. Let's see. True. I think you're gonna have you're in the output directory, so it's not gonna matter too much. I mean, that copy is a potential leak. Do I have anything there currently? Yes. Maybe that's useful, maybe it's not. Try our super small one. Maybe that won't be big enough to really notice anything. And let's see, and then in all of these, we do not want to skip if it was known to be done. Output map log. Put activity map. Memory profiler. Let's see, and then stop report. Let's see, so this is where we're going to get into, well, we get into some potential allocation right off the bat. I guess the block form would let me get into some detail about the individual steps in terms of what is the big usage. Of course, I can just turn off passes too. Oh, the other thing I wanted to do is I wanted to compare this one to the Rails one and see if there is any significant difference there, because it's normally run through the Rails interface, which might actually mean there's some stuff that's different. Actually, something else I want to try. Is it possible to start that up without... that's met process. In the rake tasks, because I don't think I actually use database for any stuff here. Some of the other things we do. Or maybe just doing any... Well, I'm running any running test. Let's see, I don't connect to the database. It's something else that connects to the database. Of course, you will actually try to do stuff yourself. So output dir would be sufficient here. Oop. This could also be done through environment variable. So that, no, actually the cache would still be doing its own little thing. Can you just be your own little directory, or do I need a full path to you? All right, so this seems to be very busy reporting. Top, certain files, ignore files, particular classes. Okay, to file. Might be useful. If it gets big. Along with memory and object count, retain due execution of the code block. Retained will always be smaller than or equal to allocated. MIME type gem, approximately 2 megabytes of retained memory, 22K objects. I'm not sure what these terms are referring to. Are those like a variable name that it allocated it under or something? Oh, number of times this string appeared. Maybe that's what it is? Is it that line number? You're not entering a line. Wow, that wrap-up stage is pretty big. That probably means you're done doing work, though. So one thing I wanted to test is just, well, I guess I don't even need to modify you to do anything because I should be up to date. Oh, but I'm pointing at stuff that doesn't check caches, so. I've probably got small file in here. Is there? Yeah. And you should be putting a different output directory. So standard run. Well, we even run without the environment. Oh, okay. So actually, right. So this was the output, blah, 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 blah. I made up an output directory there, which didn't have this. Uninitialized constant. Oh, I wonder if I need the Rails environment to get automatic file loading. Well, what are you complaining about? Maplog server. Import maplogs and load server. Oh, I am using some database stuff. To look up the server ID. Well, we can see how if that's a big enough difference to matter later. We could avoid doing the environment stuff. Right, because you're also cache disabled. Well, and actually, you've got a blank directory too. And I've only got two Ruby processes running right now, so I don't know if I'd be able to effectively look at memory. Well, I guess maybe one of them's working. No, that's not the Ruby process. I guess that counts as the background process? Well, Ruby interpreter, Ruby interpreter. So one of them is definitely larger than the other. CPU-wise, well, this one's doing a report, so. Well, this is still nowhere near the... It's doing a small file. Maybe I should try a large file sometime to see if that actually gets up there. I can even see this being the memory profiling, actually using up more memory to do its reporting and stuff. I'm not actually sure which is which right now. Well, I figured there'd be overhead to the memory profiling. I didn't realize it'd be this much. Is there any other ways to track this down? How to create a memory leak. You're the guy who did memory profiler, so you probably should say use memory profiler. Unless it's using something that does malloc. RSS. RSS. Resident set size. Is held in main memory. It's in swap space or file system. Paged out. Only aware of 3 megabytes. Yeah, because that's something that's outside of Ruby space. This is 2019 memory profile allocation by intercepting malloc and family calls. Oh, so this is for those external libraries? Perhaps? Report leaks. And Rainy Dash. Thank you for your subscription once again. How are you doing today? I should keep an eye on... Wow. I might need to find a smaller test set, but I need to figure out I want some idea of where to look first. Yeah, it's been raining here, so we weren't quite so cold. Uh, I don't know if I need to get to be getting to bed sooner or what. I'm like waking up restless but not rested. No, then leak memory was the thing I did before. Okay. The call site and it keeps track of deallocations. Total allocated bytes, total freed bytes. So that might be better for blocking up stuff. I don't know. It might just be the changing daylight is making me lose track of how late it is, or I don't know. Old red carpet leak. Instrumentation. Not graphing process RSSS. Ew. Well, how do we do that? Run at half speed. Okay, these are different lines. So one of the lines disappeared off. Okay, well, Alex Freeze are different. These are also a little bit different, but there's far fewer on that one. Hmm. There'd be heap stats. Memory profiler for Linux. Well, now we're getting into all kinds of crazy stuff. Set sequence. Okay, so the MRAP only told him about there was a problem, not what it is. Actual memory is in use. I think it's core dump files. Core dump sounds like a Linux thing, so I might have to. Well, I guess there's always WSL. Unused gems. General performance issues. Hello, Uncoded Lifestyle. How's it going? My key place. I think you're doing more than I thought. What the heck? Next unless. Small file. Let's have a look at... Oh yeah, you're doing way more than I thought. Why is this not working? So that should next unless. Oop. Wait. Where? Oh, this is the... I did it in the fix-up task, that's why. Which ended up being a separate loop. Adding new objects to an array. Okay. That's in scope. C extension, Ruby has no control. Maybe we're using some... Oh, that's a... well, that requires something that supports PS. That's an interesting little thing. Oh, and gc.stat. Tell us about Ruby memory, maybe. Number of times GC occurred. Disable, enable. Memory allocated size, allocations. We can request a garbage collection. So maybe that could, if we can determine we should be done with some memory, we can actually make it get fully freed. Stats. Note that every GC opportunity, degrade performance is only for debugging. That seems like it's pretty much for start. Start, garbage collect. Full mark true, immediate sweep true. To perform a minor GC. False to defer sweeping. So I would need something that, I would need that sort of like memory over time thing. Or maybe something from stats. To get a sense of, ooh, oh no, that was the one I killed before. Oh, and this is one of the cases where it just doesn't start for some reason. Maybe because I killed the last one, it still has some leftover state information or something. All right, so stats could be some low end. Like here's what happened. Here's how much it changed because of this step. All right, so that was... Okay, so this big one is in fact the memory profiler run. So can we even see you? We've got a couple Ruby things going on here. 100. Oop, nope. 120. I might actually need something that can graph a process over time. This might not really big enough to see some of the impact of the different stages. Okay, so it actually did free some memory there, and then it's done. And in the rake file, what we did is we skipped that. Right. And I was curious if that made any difference. A little bit. I didn't actually do the database query. But I mean, that's like maybe 20 megabytes, which isn't going to kill us. Our regular processor running into a limit of 512, I think. Still, I can get away with that for this test, and that's just stuff that won't be in our way. Well, since we're still waiting for this fancy pants one, so we've got, well, this would have to be including a create a memory leak. This was talking about MRAP, memory profiler. It keeps track of all allocations. Well, that could be an overhead too, maybe a different kind of overhead. But you do your own reporting. There's not like a handy method, so I have to know what I'm looking for. Although I guess this is... No, it's by location. And then for a very, let's see, we've got this. So the main things we're worried about. Now you see, we're not going to trigger updated files here, but I wasn't seeing a big change between the two passes. Do I have to require this? And where do we run across you? Is it just GC dot? GC dot start. GC dot stat. If indeed it does that. Oh, well, I should start printing something. And it printed it with a terrible, oh, reflowed, okay. So are you still going? No, you're still going. Object data. Does that mean that you had a whole bunch of references to it? Or you parsed it multiple times or something? Well, I might see that many copies if each pass did its own thing. Oh. Oh, it only reflows the latest few. 121. Oh, these are strings. So these are like all the object IDs. I might have to customize this. Does this mean these got left around? Or is it the times they were allocated? Allocated string report. Oh, that's the number of times? Ew. Yeah, so maybe, well, the numbers are going to be hard. I'd have to convert this, maybe symbols to in turn some basic things, but like start time we can probably... Okay, so what do we got from you? I could probably see about a better formatting for this. Maybe like a formatted JSON or something? Which of course I don't have that. I might have it somewhere in here. What was it in Ruby? Well, we've probably got. I don't write that many JSONs, do I? Maybe in the web interface. Parsing, generating. What about formatting? Ops. Indent levels, so it'll be space. Array new line, object new line. Not a simple nice print, huh? A pretty generate. No, it's... Let's just see what that looks like. Genrat. You see, this is why I didn't want to just copy that, because I would have copied the error 5 times. Nope, because we'd have to actually do... Is it puts? That's a little bit better. Okay, allocated strings. That I don't know how much that runtime memory is taking up, but it's interesting. Okay, object over. Is that bytes or instances? Well, an array can't be 1 byte, right? Do we really have that? Well, maybe we have one of those for every object? So object data. Okay, so what's our progression? So count, heap allocated pages, available slots, marked slots, malloc increase bytes limit. Yeah, it's too late for this. Retained objects. So object data probably has a database of all the objects. 7,000 almost seems like too much. Geometry lib, well, yeah. Object over hash string. The hashes are almost a little bit concerning. Retained memory. Well, that is a lot of memory. Object data, object data. Well, we define an object set. I could probably arrange to purposefully clear that at the end just to get it out of the reports. And I can actually clear that before doing act maps. So that could be some more memory for that. Increase limit. Remember WB unprotected objects. Old objects, old object. Well, there's a lot of old objects. Increase limit, minor GC. Okay, so we'd have a lot of GC counts. So it's not that it didn't do garbage collection during the run. Lots of freed objects, lots of allocated objects. Some of the strings might help with that a little bit. Not sure what count is. Yeah, this is not super informative. Maybe I can read up on what that means. But I'm not really sure which number to watch for like how much allocation happens during a step. I mean, just getting these out into a, I don't know, CSV file or something might make it easier to look at between steps. Integer objects, fabulous. These are allocations, which dynamic language, we kind of had to expect some of that. Allocated objects. Okay, so maplog 4. You're actually going to be line split. So you would be allocated and then freed. We could maybe avoid that with some different parsing techniques, although I guess you still have to make the string of the results somewhere. So that should have been freed. Output activity map. That's an integer? Or no, that's probably the tile coordinate pair. So I'd have to come up with like almost like a hashing scheme or something. I'm not really sure what else you can do about that. It's going to be indexed by something. Yeah, because the tile coordinates are like almost unbounded. I mean, technically bounded, but you can't easily compact it into an integer or anything. Maplog 59. That's an allocation. Okay. I guess those are the integers. Okay, so this is tile coordinate. This is the tile subcoordinate. Well, no, a tile subcoordinate could, in theory, be reduced to an integer because these are all going to be 256 by 256 tiles. And just to change how we interact with it in all the places. But apparently it's still going to allocate an integer. Look at objects by file. Well, we already kind of looked at those. Wow, I never realized integers were allocations. Strings, we saw a couple of strings we might be able to do something about, but the numbers are going to be hard. Total memory, yeah, the array splits. And I was trying to process each line and move on so we didn't have to keep that stuff around. That's a lot of allocations too. I guess really retained is what I'm concerned about is runtime size. So the start time thing is would be an easy win. I don't think it's going to make too big a difference, though. Well, it'll get rid of a bunch of these strings. I think retained is actually the issue. Well, that was most of the object stuff, which we can. Let's see, map process objects, which we can actually be done with before we start doing this stuff. Or actually, well, okay, it's a problem. We pass these to these things. So one of the things I'm looking at is possibly recreating these as needed, because they might be keeping a little bit of stuff around. That might mean, yeah, so technically we're doing this for each log. Most of the time there's only one log. That might mean rereading the object data on every file if we were processing multiple files in order to dump it for activity map. Okay, allocated, retained. Well, yes, it's in the library. Yeah, it's mostly the object data. $18.54. I'm not finding like any big. Well, this is at the end of the process. I guess technically. What I'm interested in is stuff that's kind of still in the middle of the loop. 'Cause maybe by the end it's fine. Okay, so object size. Hash of over and 18. Is your object over. I guess I'm counting on this only being used in that file. Or also being loaded in places where that's loaded. Yeah, apparently. Still, that is per object. Which I guess if that's 600 kilobytes, not nothing, but it's not hundreds of megabytes either. Oh, impact of loading a gem, okay. Long-lived memory use attained due to execution of the code block. During a code block. Smaller than or equal to allocated. Oh, or maybe I need to do freeze? Would that do it? Two point three, that all string literals in the file are implicitly frozen. Default, okay, so that was counted out. Not allocating new space for the same string. This is like if all frozen, it's just not doing dot freeze. And there's 2016 again. Same string object, cloning objects. And it might be a hint to the system that it can't change. Use the same string object. But is this the... But this is a 2016 article. But it's not like dot freeze, because you're kind of still creating it and then freezing it. But he's talking about benefit from dot freeze. There's 2017 again. I think this just makes it not modifiable. I don't know if that actually helps performance. Yeah, that's not helpful. Garbage collection. Dot freeze. Join dot freeze. That's further modifications. Make an object immutable. Okay, yes, we know that. Frozen object can't be modified, are only instantiated a single time for each unique object. Retained to be reused. So actually, I don't know if that would be useful for my numbers. What was it in MapLog where we had this thing? Yes, I don't know if it would be useful for some of these things. Maybe single letters it optimizes better. Retained memory by location. Object data object, that's retained memory. That was under actually allocations, wasn't it? Allocated string. Start time, okay, from a couple of different places. Oh yeah, well there is space. Which I added, I moved the lines down. Unfortunately, I have to do this. Well, I have to do this rather slow process. Although I guess I don't have to do all passes. Would that make a difference? Now, it'll make a big difference the number of times that stuff's called. Yeah, there's a 2.3 later. Once again, this is an article from 2016. Frozen string literal might be kind of useful for some of our stuff here, but this is not actually addressing our memory size issue. So actually, which one was I looking at? Well, there's Rubocop, object space. That's kind of what Memory Profiler is doing. Yeah, MRAP, which just does growth and Alex versus freeze. Oh, but it's calling MRAP on a thing that includes MRAP. So, okay, so this is actually a outer program that's also using a library. And one thing we did see from the GC stats, the other report, is that we did, let's see, so we're running minor G, yeah. Even before we start, we'd run GC count several, we'd run GC several times. So it's not that we're never reclaiming memory. And the retained stuff, well, what's retained might be different between these steps than at the end of this block. So I might need to do some, oh, are you done already? Retained string report. Okay, well. New line. Well, the file path thing probably isn't going to be too huge. Yeah, there's the F again. Although still most of them are in MapLog. I'm wondering, where is the... No, I guess... Oh, okay. We do still have this open. Would this make a visible difference? Oh, experimental. We can just see if it matters. You know, I love our processing time was in the later passes. Chain string report. Oh, F isn't even up there anymore. So now, Can we just put this back? I mean, maybe that one is a big enough string that it's still kind of worth it, but... These are going to be tougher. These are like all item IDs. Yeah, and then map log. Let's see, 52. Yeah, we're pulling out the ID from a string. Key value first. Well, we've got the F. We've got a 0, a V. I can't really help with the numbers much. Let's see, 22. This is probably going to be, if we're doing, yeah, the letter encoding. I mean, I might be able to make a lookup table for that. It's a surprising number of those, actually. Or is this by bytes? Allocated string. Yeah, still lots of zeros, because they're actually producing zeros. I mean, maybe you could special case that one to some sort of constant. Retained objects, yeah, it's mostly object over. The rest is too small to be super concerned about. So we could maybe clear the object over before doing the activity map. We'd have to rebuild it on every pass. It's allocated, which means they could have been cleaned up at any time. And by the end of the program, I'm not seeing anything super terrible. So, let's see, we're currently doing this pass. Let's try to at least get rid of the object over allocations. Although this won't get the input data file as much. Okay, 1, 1, 1, 1, 1. Oh, we only retained 0 once. And then here's our allocations again. I think. Retained... Oh, okay, that only retained... Well, it could have been a very big hash. If we have retained objects by size... Tile set... Then that would be more interesting. Maplog file tile set. Yeah, I don't know if that's telling me bytes. And is this retained memory? Oh, right, we have not yet had a chance to clear this object. If we've still got a tile set around, that's maybe not great. But it should have been an argument to this. Of course, what's the what was I looking at for garbage collection stuff? GC.start. Oh, that default to true. Retained objects by class. Okay. Well, it wasn't in objects, but it was in tile set. Might have been a string or something. Retained memory by class. Yeah, okay, so that's not long term, and maybe doing a cleanup after each of these steps would be useful. Since there's going to be a large amount of garbage there. There's tile. There's tile set. I guess that the tile sets contain hashes, so maybe there's something kind of hiding in there. And we're back to allocated. That is not by line, by location. 14. Now, I guess tile.new. We weren't showing tile as a retained class. Maybe it's this hash? All right, let's, I might want to keep these immediate cleanups. Oop. Oh. Oh, that was timestamp fix up. That doesn't. I probably shouldn't have even done that. I mean, you could almost do a garbage collection per loop. Because we're going to be basically done with a large object at the end of each pass. Okay, so you're actually getting... Well, we're running with the memory profiler, which is keeping extra information around. Let's see. So the easiest place to do this for most of the things would be to say we replace our span, we replace our tiles, and then clean up. See now, I've actually freed them here. All right, retain string. Right, because we've done garbage collection, so I guess that freed up some of the zeros and things. Object data, hash. The object over, which we're kind of keeping around to reuse between passes. There's still a tile set. I don't know if we're like allocating a string, or maybe it's this hash. That worries me slightly. Because the tile set object is gone. The tile object is gone. That should have freed up references to the internal tiles. And a tile set is actually the big bulky blob of memory. Do we do tileset.tiles somewhere? So tiled. I think by finally usage, I kind of do that. So we're currently doing with output map log. Tile set. So write tiles takes the tile set.tiles. So that does grab a reference to it. So we're passing around the subtile, but this function should have ended and therefore lost its reference to it. Retained objects by file and objects by location. Well, that's 2 objects from there. So that's not going to be all the individual tiles. Unless it's not counting the members of a larger set. But somehow we're getting a... Huh. Maybe it's a handful of individual tiles that had a trailing reference somewhere? Hmm. 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 All right, we're removing these. Or so now you actually use a different system. So it should be about the same yield. We replace them with brand new objects. Replace them with brand new objects, destroying the old references. Now the problems the bulk of the memory increase we were seeing was in the other passes. This process could kind of run to completion without hitting the memory limit. I did not update map process. And it's not surprising because we're only keeping count rather than entire huge lists of things. Hash string integer. So yeah, you're not directly using the object map stuff, so it wouldn't be touched by you per se. By location, hash. Output activity map. That means it's the require statement? No. I guess it does use a string. No, you are the... Well, family trees span... There we go. Yeah. But just for requiring the file? A retained memory by location. Wait. I wonder if this is the tile arrays. Oh, it says it's hashes. And that is in fact what this is. Tile equals tiles. As I didn't deliberate. Well, tiles should be scoped to this block, right? That's a little bit worrisome. What are we doing with JSON? That's where it actually got called, not where I called it. Oh, this is probably some of the tracking files we use. Well, I guess if that's got something, then if we're comparable to that. Yeah, process. As long as this thing sticks around, then its member variables will stick around. All right, so I guess another thing I need to check, and I'm going to have to run a normal-sized file to see if we get comparable memory usage. This has the memory profiler stuff in it, but I guess that's easy to remove. All right, so a recent file. That I might have been looking at. Actually, I didn't look at yesterday's, but it was pretty much the same as the one before. This will take a bit longer to run, and I guess to be fair about it, we have to run everything. Even though it was really the first two passes that are peeking out the memory. One 6 0 7 6 2 8 2 8 3. So you were you, which I could have used a separate copy of things. Base time undefined. Method for nil class. Oh, that's the wrong window. A7? Undefined method. I changed the length of this. Now it's all cut off. Nil class. Oh, this one has a history and it doesn't exist. Which shouldn't actually crash it, but it is a bad situation. I don't remember where our last reset was. I mean, this would probably be close enough. That may have gotten a truncated log as it was. When was our last reset? Okay, so that file. Huh. Oh, I was probably doing this with activity maps, which didn't actually need to base off of anything. Although, maybe the base file processing is part of our memory usage? In which case, I guess I could do like the first two sections of it. Zero 3997647. It's still checking to see if it exists. On 60399. Seven, 647. But I don't have this break file there. We are in U. No, this is in here. Okay, so 400 megabytes, 500 megabytes, 600 megabytes. That is comparable to what we were seeing. That only dropped us to 400. So it's almost like I need more information about my runtime allocation. 423, and we start running again. This is going to allocate even more stuff because it's more detailed. Okay, well, the GC checks seem to be knocking it down a little bit. But I wouldn't be surprised if we're getting like a peak memory situation on running on Heroku. Yeah, 522, that'd be over. Not too much more while writing out, but some. Oof, we had a big bump before the end there. Oh, no, this is just processing the next chunk, which is the big one. And of course, some of the memory is actually the file we're processing, which makes me wonder if I need to try like writing it out to a temp file and then streaming it through. Okay, so we did get a drop there. So maybe the garbage collect calls are doing some good? Oh, no, because I've still got the file in memory now. I won't have freed the object data yet. Hmm. This also suggests I might want to do, because if there is any like sort of anything kind of left over, I wonder if I should be doing this pass first. This is going to have the lowest load. That wasn't quite the details I was looking for. Let's get per process. Yeah, this is still... This is still total, not... Yeah. That does seem to be building up a little bit of stuff over time, doesn't it? I mean, admittedly, every layer is a little bit bigger, so it doesn't necessarily have a time to clear out. Well, that we saw that written down briefly. It probably might be some sampling frequency. I guess I'm not sure which number to be paying attention to as far as GC stat stuff. And this is a bigger layer. I think we can't see that it's going to be the smallest pass. So if we do that first, it'll likely complete in the lower memory. And then only have the big stuff where it's actually going to... so only the last step goes slower. That potentially to be a small improvement. So we were messing with the GC stat stuff, which... Well, I have modified this to do the cleanups. I would almost want to look at this like in the middle of a process to see what the increase is. Heap allocated, total freed objects, malloc increase. I don't really know which number I should be looking at. Total allocated pages? And I could be looking at individual passes and where it would be useful to freeze things. So it's interesting that they're doing like this, that it like inline is sufficient to do that. I guess it like looks at it and then you can still like call things on it to collapse it back down, or it's looking at it in the parser. Yeah, that's a Linux thing. So there are some levels we're certainly not going to here. What the actual memory is in use. But that's some really low level stuff. Dump memory. At least 3 memory dumps. So you have 3 more dumps you need to split a diff of these dumps. Dump memory. Dump memory, object space, trace object allocation start, run garbage collection, and then dump all. Memory addresses. Potential leak. Objects of size. Oh, retained string, restrained data. And it tells us where it came from. Well, we've already got retained information from Profiler. And there was one other program, which was the, I forgot now. Is it here? MRAP. Yeah, but this is something we don't have set up right now. GC start, MRAP clear. Do it again. Don't check allocations after this block. So this gives you growth attributed to a line. This might be for the extension You know, something malloc and family call. So I think this is for like, yeah, the fiddle things. So we could save a little bit by not doing the server ID lookup and not running map logs with it in the Rails environment. I need to check. All right, so we've still got this GC stuff. So we do the small one first. I'm not necessarily doing this process, which involves copying a large string. What I kind of want is a way to just say, hey, what's my total process memory? And actually, one of the things did have, we just like did a shell execute PS, which, let's see, so we're now in here. Like, can we go back to this? But it had options. All users. For specified PID, there's probably a way we can get our own PID. But this doesn't seem to have the RSS option. Current rake task. Core process. Not available on all platforms. So I don't know if that would work, even though we've got the little bit of Unix extension stuff here. Okay, it does get something. Specified P. Now, I don't know if that was the same syntax we would have on Heroku. Oh, I didn't really redirect this anywhere, did I? Okay, well, that shell's dead. Maybe it's still dead. Okay, it didn't like that much. So it might not be the same process ID. If we take this out, what does that look like versus what we get? Well, it's not formatted very nicely. So 88140, and yeah, totally different process IDs. Well, oh, WinPID. Well, maybe you could grep for it. And I don't know that I see any memory information there anyway. Well, UID PID, UIDs PIDs. Yeah, no, that Yeah, the Cygwin version doesn't do very much. So we found some interesting things related to string allocations. I think our data structure is fundamentally large. We're like using string keyed hashes and lots of data. Never really measured it before. It would be quite the project to shrink that down. The tile coordinates are a hard one. Because you've essentially got, well, we'll never go all the way down to 232-bit integers, but I don't think they're going to be that much higher. That needs to be some kind of sparse memory. In an individual tile, in some situations we have sparse setups. I guess map logs are pretty much just recording all the data about everything, and we're probably keeping around like Ruby objects and string versions of things more so than needed. At the beginning, there are big wins for, well, of course I took all this stuff out. You certainly have the most passes. Could go to a file. Default is 50. Include or exclude certain files. Explicitly want to trace allocations. Start, stop, preprint. Oh, yeah, I might be doing the larger file, which I don't think that I'm looking at the strings right now. It's going to make that big a difference actually. That was more about if we had made any difference in net size. Oh, and then the other thing was, so you did the server lookup. Load server based on logs.server. Where do we actually determine this? Collection.each do load collection. Is built from servers which only has that setup in it. Dot sub slash So logs.server. Okay, so there is big servitude at 101.5. Actually, that one didn't have the slash. Maybe some of the other things I was doing that had slashes. Uh, well, I could almost just say if not equal to so we've got our generic version. But we can save ourselves 20 megabytes or so. Oh, I mean, this sort of does it too. If we just left that. Well, so this is always assigning it. This would say if it's that. Did I not? Oh, and we still had other stuff on. I need that. Okay, 111111. Those were retained objects. This is actually allocation just as a performance thing. Some of these concern me, but I guess some of them are going to be like option objects and things. Some of these concern me a little bit, but I really don't know how to trace down the actual objects. I wonder if the garbage collect is actually messing with some of the allocated stuff. It's like it collects it and then it's not, doesn't have a record of ever being allocated. It's like I'm not seeing all those individual numbers anymore. Let's see. I don't think I'm actually going to need... Like, this little thing is never going to get the individual breaks. I don't know. If GC erased an allocation... And that wouldn't actually be effective tracking of allocations. Then the big long report. I could probably cut down just like the biggest pass for this one, really. It might also be interesting to see if the download the raw data to file, to temp file, and then try to stream the temp file. And it wouldn't be huge, but it would be another 50 megabytes or so on current file sizes, depending on how much the file system buffers it. For that, I think I would need to commit and do a separate little things here. So right now we've got some extra GCs to try and reclaim memory at opportune times. We've got some memory allocation optimization that might help things run faster in general. And we still don't have to allocate those strings, although those should get garbage collected and replaced at a pretty regular pace. Do I still have... Yeah, I've still got these stats in here. No. Okay, so I think I took that out. Maplog, rake. You're pretty much running the same thing, so you shouldn't need it either. And then I don't think FixUp needs it. Unless it's doing a separate check on server. Oh, it is. Because that was just to connect to Active Record. Now, currently, I think the map logs and the... Oh, and you want to get fixed up, too, in a little bit. Monuments are still doing a little bit of database stuff. Well, lives are definitely doing it. Monuments, I think it's kind of importing database and then exporting. So you're all the memory profiling stuff. So probably you're doing all the activity maps, which are getting larger and larger and larger. No, that's all the detailed stuff because this is a small one. So I'm just curious. Let's see. So we have, well, we actually had more. Well, before I was kind of looking at the head of things, and this had all of these. I think I did 2 befores. And we had lots and lots of garbage collections in the middle. Yeah. Total freed objects. I don't know what count is. Heap allocated pages, heap sorted length. Available slots. Total allocated pages. Maybe I should be looking at it in the, when they're at a high memory at time to get a better sense of that. Did I leave this on the intermediate sized file? No. Maybe just because I had all passes on. No, I didn't have all passes on. I did this thing, which is multiple passes itself. And I think before I may have had the garbage collect beforehand, so I had to analyze a lot more stuff. Well, retained strings actually didn't get that much different. Okay, now here, yeah, so this is allocated string report. So this stuff does get affected by garbage collection. Right, 5. Oh, line dot split gets all of these numbers and it ends up allocating a lot of zeros. Yeah, and that's converting actual values. So I don't think there's a whole lot we can do about that. Short of lookup tables. And allocated objects by file. Well, yeah, by file isn't really going to help me narrow anything down. Yeah, all the integers. Yeah, that maybe a different parsing method would cut down a lot of allocation. The tricky part there is you have to deal with any of the possible file corruption. And I might have those problem things noted down here and there. String scanner class. Ruby parsers, not just one parser, multiple parsers, different versions of Ruby. Well, he's talking about performance hotspots. Parsing Ruby code. Okay, so that's allocation stats. It's probably similar stuff, but well, gives you mem size versus mem size versus count. Version creation. And Luxing phase. Stir.lines.first. split the entire string. Returning enumerators. Oh. Only caused once. Freezing strings. Yep. Judging from our allocated strings, we've already gotten the real hotspots for that, though. One other place I could see that would be the doing lookup tables for some of the character mapping things, which would be kind of on a different pass. Let's see if we see the letters in here, which we're not doing this one. It's all numbers. I mean, I guess you could do lookup tables for like the first few numbers. I don't know if that would actually be a good value, especially since some of them are negative. We do these a lot, though. So these are all in MapLog, or mostly in MapLog. So we're creating these by splitting the lines. So allocation-wise, if I could get a different parser in there that didn't have to allocate things. See, the coordinates, and I've kind of kept object IDs as strings because you do have other things in there. Okay, so we've got arc start. I guess is 2F doing the parsing there? Well, I mean, this is like creating all the strings. And we've got, well, it's really only MapLog. There are other things like this. This could be an interesting thing. All right, so map, process, any other easy ones? Final placements. Now, did we have the thing where the garbage collection was removing objects that we can examine? No, we still got all these. MapLog, 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 MapLog. Well, tile set 1. Still, if there's one tile set that's still around, that could... that's in tile set. So there is a retained object there. Because a tile set is like the big thing. Put final placements. Yeah, well, that's not necessarily a frozen string, but it's not going to get used very often. Yeah, we're only down to like, well, but if it's the right object, then it becomes huge. And I don't know if I have any way to identify a large object and then say, where did that come from? I guess this didn't have as many passes as the activity maps did it like 24 times. Well, that might be why MapLog wasn't as big here. And do I not see? Yeah, the key index file didn't show up as a big thing, but maybe that's the garbage collection again. Not letting us report on things that no longer exist. Or, well, maybe I added it to that file and it used that freezing when it was doing those conversions. Yeah, because we did add it to here, so I guess we're getting some optimization out of that. I should have fewer retained strings here, so that has to be, yeah, I guess I can only use garbage that actually left, and we started doing garbage collection. Okay, so that was experimental code. I don't necessarily need to keep this around. Means I don't necessarily need to keep that around. Let's see. Actually, I just don't want to make any changes to this file. Commit any change to this file. I might still be using you a little bit. Well, still change the gem file lock. Actually, that extra freeze there is probably unnecessary. Since we said frozen string literals. And we turned off all of that stuff. Yeah, wasn't as helpful as I thought. Output final just ended up being a little bit different. Okay, that we want to leave out. Is potential reordering there. So git add. I almost don't care about the gem file lock, so really it's lib. Well, I don't want to do lib because I've got a new file there. So all we've done is we've reduced some allocations and added some garbage collections. Have not yet found anything that's actually a big problem. I guess one thing I haven't tried to do is see if I could like get it to idle for a little bit. Well, no, because we have seen the memory drop when we had activity map later, and it actually dropped down to 100 something. So it's definitely able to shrink again. It's not like a huge leak. All right, and then over here, okay, so we've got a mix of stuff here. Eplogs. All right, it's seeing that weird. Oh, we actually we shuffled everything down. Oh, I had noted this. I wonder if there's actually useful information there. Yeah, the memory usage upgrade. Too many workers over time, forking behavior. Debugging runtime memory use. Yeah, I forgot to look at this. How fast allocates memory. Memory usage is a high watermark. Memory hungry, it just went out. The long lasting, frequently buck under power users. Yeah, this is actually Rails specific. Not, I won't really necessarily help with my background task. It's more of a profiler specific thing. Oh, well, there's allocations. Now, derailed says it might be a Rails-specific thing again. Yeah, Rails. So, not necessarily going to help us. So the changes here, oop. Don't want that one. Don't want that one. So our main thing is, well, we did the ActMap first because it's the smaller memory. And do not load Rails and for map logs. And this is going to reference the other thing because I updated. Well, actually, no, I didn't have the. I haven't actually run anything since I committed that. So this should be a no-op because all our data files are up to date. And then there it is. So that might help a little bit. Other things, let's see, what do we want to look at? Oh, if is it S3? No, because it's the map log. Server. On an individual file. We keep around contents. That's log file new. Also has contents. Contents or equal get content. It would become a little bit more like maplog file. Different kind of maplog. Maplog cache. Oop. File.open, which I think can effectively be streaming. That uses mtime, so that would be, we'd use the date information passed in. We could still make it lazy. But instead of doing a string IO, well, I guess every time you do this, you'd want to have a new file position. That is allocating a new object every time, though. So you would say if we fetch, then we have to write a temp file. And then every time we open, we do that. Which might let you free up the string buffer of the contents. Well, it's already late enough. I might be able to get something out of that. And I think it might even be able to get that deployed for today. See if it runs any better. I mean, we're still going to hit the memory on the final step, but maybe it's only going to begin the final step now. So unfortunately, we're not quite done because we still have... I still have to check if that makes a difference, and you're going to have to check on a larger file to be able to see that on overall memory usage. But it's a 50 megabyte file. It's 50 megabytes off the top. If the file streaming actually works, that could keep us from going over the limit. Thanks for watching. Thanks to Rennie for the resub, and for all of the other subscribers. Thanks to everybody who hosted me. Any other code going on here? Well, Rennie's actually playing. Actually, yeah. That's what I'm usually on. It's got a little bit late-ish today. Let's see. Sleepless Person, not sure what project they're working on. So Flipper says cool to hang out. Ambadev is working on something. And that's a place cool to hang out. Thanks for hanging out with me. Goodbye, and until next time.